for security, the all the accounts that needed to be done. So if uh, in my doc sharing documentation, and I think at least either in the first or second screen lead session, I mentioned that take all that stuff. It's like pages of it. Take it all as nothing more than a recommendation, kind of like traffic signals in Mexico. Okay, use it as perhaps a starting point, perhaps something you choose to ignore. And the reason being is actually twofold. Some of y'all already work in the field. You've got a little bit of background. You may have used the tool, and if the team agrees to leverage that expertise, the last thing you should do is not take advantage of that. That's number one. Number two is you don't have time in 8 weeks to go through every one of those tools and the nuances of those tools and see how they're going to integrate together to use for a team, especially considering the fact that some of those things are obsolete or the versions have changed and the way they work has changed. So the documentation that the school provides, I mean, it's a start, and I'm not throwing darts at what they're trying to do. They're trying to give you options, but some of those options are really non-starters. But guess what? They take time to figure that out. It takes time to go in there, log in, and find out that, wait a minute, this isn't what I expected. Well, nope, I can't use this now. And you might have wasted a couple of hours doing that. Okay, so only thing I require, okay, like any good team, is that any tool that's going to be used must be defined. The team has to accept it, and the document has to define it. It has to define it in terms of what the tool is, what purpose it's serving, and why you selected it. And out of those three, I'm looking for that last one more than anything. I want to see what kind of critical thinking goes into your selection tool. I got to tell you, even if the answer is, hey, it's the best one we found based on the time we had to look. It does this and this and this. We considered this other stuff, but we just ran out of time. That's honest. You can't argue with honest. You can never argue with honest. Okay? So, but I can argue that if it's not defined, I don't know how honest it is. So it's up to y'all to define it and explain to me why you did something. But in terms of what you select, I do not care. So you define the tools in terms of what tool you're going to use for documentation, what tool you're going to use for presentation, for coding, which means language, or development environment, for testing, for source code. Even I mean, you could select and say, we didn't have time to do a source code uh, system. So team member XYZ is our source code repository individual, and here's the process he or she is going to do to make sure that we don't walk on each other's source code. That works too, okay? In a big team, that probably wouldn't be optimal. Teams that the last team I had 350 people. There's no way I can manage that without a tool. But then again, the tool I had cost $175,000 per year. So we're in a different environment. Okay, but the environment you're in is one that's going to follow a software development process. That environment's not going to change. The tool may change because the scope of the application is different, the size of the team is different, the timeline is different. That's what you're dealing with. You're dealing with sitting back, reflecting as a team, and saying, okay, here's how we're going to do business. Here's how we have to do business because we've got 5 weeks left. So we're going to do this, 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 and this. We're going to use this, 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 and this. This is how we're going to use it, and this is what we're going to deliver. End of story. That's what that document that you're putting together for me is all about. Did that answer your question? Did everybody quit?
No.
I didn't quit. I was there earlier. It answers the question now. Yeah, I missed that. I missed that response. I just want to make sure before I go off that the question was, did that answer the question? Yes. Okay. All right. So here's what I want to talk about today. Last week we talked about requirements and design. Today I want to talk about design and coding. And in between that, parallel with design, I'm going to talk about test procedures. Okay? So this is really phase 2 and 3 of the software development process. And I don't care what process you're talking about. Okay? I don't say, hey, today I'm talking about Scrum or Agile or JAD or RAD or Waterfall or Rumpelstiltskin or any of that kind of stuff. Okay? Because I don't care how you're going to do business. I don't care which one of those models you use. There is no way that you're going to get away from doing some aspect of requirements gathering, some semblance of design, some coding, some testing, and some implementation. How you do that might be different based on what framework you're using, but this is no different than problem solving. Okay? I don't care which engineering discipline you use. When you're going to, there's certain steps you have to take. Right? You figure out what the problem is. Once you understand the problem, you talk about what the options are. Out of the options, you generate some solutions. Out of the solutions, you come up with a strategy for implementing them. When you implement them, you come up with a strategy for assessing their validity and verify that they're working, some kind of feedback loop. If it works, you're done. If it doesn't work, there's some kind of feedback loop that takes you back around to trying to understand, did I understand the problem right? Did I do my design, my solutions right? Blah, blah, blah. Same thing. There are hundreds of design approaches, but those steps are always in there someplace. It's the same thing with software development. Don't care what you do, don't care how you do it, but these five little steps are going to be in there someplace. You can't get around them. If anybody finds out or figures out how you can not do one, you got to call me, because together we'll write something up and we'll become billionaires, because we'll save people tons of money. Okay, but we truly have to be able to eliminate one completely, and I'm saying that can't be done. All right, so we talked about requirements and how they kind of step into design. We're now talking about design. Design is how you're going to satisfy the requirements. And there's all kind of ways you can do design. We talked about this last time. I'm going to touch on it a little bit again. I don't care how you define it. Okay, you can use, but normally there are at least some things that you have to include in some way, shape, or form. We normally have two major phases in design. One's called preliminary design, and the other one's called critical design. In preliminary design, I call it the smoke and mirror phase, because nothing really works in there. What we're trying to do is just kind of show how things are going to work. And it's a smoke and mirror phase because it's got stuff like, it shows screenshots. You come up with a screen like a storyboard. Hey, this is what we're saying the screen's going to look like. And you can do that in PowerPoint. You can use it. A lot of times I used to use Visual Basic for that. I didn't get any real coding in Visual Basic, just enough. I used Visual Basic's tools to sketch out what the screen was going to look like, because I'm atrocious at drawing. The other thing it has is navigation. How are we going to get around the screen? Are we going to use pull downs? We're going to use some kind of menu. We're going to use a text bar, a regular command line, whatever. Right? That kind of thing. If you have a screen layout, I'm sorry, if you have a report layout, what's the report going to look like? Like an output screen. Or if it's a report that goes to the printer, what's it going to look like? Again, smoke and mirrors. It doesn't do anything. It just shows you. The other thing you generally have in that preliminary design is a data dictionary. None of the data has any relationships at this point. There's no structure. There's no records, whatever. But it has a running list of all the data. And that's kind of important early on because normally you can generate that pretty quickly. But it's important because you can give that to the customer and say, hey, here's all the data elements we think are important. They can go through them pretty quickly and say, hey, medical ID is pretty important to us, but it looks like you don't have it here. Well, that could mean that you might have missed a requirement. So better find out sooner than later. So we normally include a data dictionary in the preliminary design. The critical design is kind of like the next step. That's got the business rules, the algorithms. You use things like flowcharts, pseudocode, something that I don't know if you guys ran across it in your reading, Nazi-Snyderman charts. It's two guys that came up with another way of depicting ERD. Those you probably came across in your reading, entity relationship diagrams. Generally, when you talk about database stuff, you have your ERD charts. The other thing that has now you do have your data structures, which could be done with ERD charts. Structures now takes data and it puts them into some kind of record structure. Hey, name, address, city, state, social security number, that all belongs together. And we're going to call that employee record. Okay, good. Okay, now they have meaning because that meaning now relates to the business rules. What are you going to do with that data? So that's your design. Topology always nice. Picture is always good. Okay, high level enough. Well, let me back up. Let me read. Low level enough that people understand what the application is doing, but not so low level that it takes 30 pages to depict. So high level enough that you can do it in a couple, 3 pages, but low level enough that they understand the full scope of the application. Not an easy task, so you got to do a little thinking. That's where the critical thinking comes in. And as a team, you all need to discuss that. But that's what you're trying to achieve. It's the classic calculus min-max problem, right? So, all right, that's the design part. Now, while you're doing design, this is important. A lot of people miss this. I don't mean students. I mean professionals. While you're doing the design, remember, what does design do? It implements the requirement. While you're doing the design and saying, here's how I'm going to implement the requirement, you are in a perfect time to also say, this is how I'm going to test that requirement is met. So you should always do your design and your test procedures in parallel. And here's why that's important too. The design is done by software engineers, guys that make that entry level. When my son's a software engineer, but he got his first job was $75K, just out of school. That's a software engineer because they know these guys are going to be the architects of these applications. A programmer, which is also a very important job, but they don't expect them to be the designers. So programmers start anywhere between 25 and 35K. Software engineers, when they get a design, they in parallel do the procedure because when they're done with that design and armed with the procedures, they take that package and they hand it to a programmer. Sometimes a computer scientist, which is really a programmer with a math background, or sometimes just a programmer who's information uh, specialist, information resource person that learned the language and is good at the language, may not have as deep of a math background, so they're not a computer scientist, but they can still code. But they hand that package to those folks, total, that basically says, here's what I want you to code. I want you to code this design, and this is how you're going to test your code. This is the procedure you're going to use. Okay? So they get the full package, and they're not allowed to raise their hand and say, hey, I'm done, until they're done with those procedures. Those are unit level procedures. So those three things the two things go together at the same time. Then they get handed to the programmer, and the programmer then codes it. Okay? Now, a programmer is always allowed. In fact, not is allowed. It has to happen. They test their own code at the unit level. But as the program comes together, okay. Now, I understand in your situation, it's probably only one person doing the coding, maybe two. In a real situation, there's probably many, many programmers. When that code gets integrated, no programmer is allowed to test. That has to be an independent person. In your case, once that application starts coming together, you need to have one of the roles needs to be software tester, and it cannot be the person or persons who did the coding. It's got to be somebody else. Okay, and then they generate the test reports for that. So, what do we have so far? We have the big three, actually the big four, really. We have the requirements now we've talked about, the design, the test procedures, the coding. Okay? So, taken all together, that forms 4/5 of the requirements traceability matrix. The requirement points to design, design points to code, design points to procedure and design point to code. And eventually, the code points to the test routine, the test report that says whether or not it passed or failed. Okay. All right. So I want to talk about one more thing, and I'm going to open it up for questions. Documentation. That document that you have, that you're working on, everybody's updating along the way periodically. There's only one document that you're creating for this whole thing. Okay? It just keeps getting incrementally updated as you go along. It'll have the requirements, the test procedures, it'll have the design in there. What it won't have in there is the code. It makes no sense to make everybody copy the code and stick it into a document just to add another 20, 30 pages. The code can stand by itself, but it'll have some kind of indication of what design it's implemented because of the requirements traceability. But here is the documentation I need for the design. The beginning of every code module. Right? So depending on what language you have, for instance, there's the language tells you, how you start the procedure out, or the function, or the package, or whatever you're using. Okay. Above that, every language also has a way to put comments in. C++, for instance, you have two ways, right? You can do a backslash, and that's a comment. Anything that follows that is a comment for that line. Or you can do a block comment, like a backslash asterisk and then an asterisk backslash. And anything between those, could be multiple lines, becomes a comment. Okay. However you do the comments, I don't care. But here's what needs to go into the beginning of every procedure that you do. It's called a preamble in the business. Preamble, a preamble. The first line of the preamble should say module name. or package name or function name, whatever it is, colon, and then whatever you want to call it. Totaling algorithm. Okay. Next thing, programmer's name. Name or names of the programmer. One person did it, one person's name. Two people did it and worked on it together, two people's name. The third line, the date that it was programmed, the date that it was originally written. Fourth line, the version number. That line gets updated every time, or either updated or you put a comma and you add the new update. So if the first one is 1.0 and you made a change to it, you either change it to a 1.1 or you put a comma 1.1, and it shows the whole history. I don't care how you do it. But either way, every time you touch it, it needs to have a new version number. Next line, I think it's line 5 now. Description. Short, 2 or 3 sentences, well, 1 or 2 sentences, what that module, subroutine, function, package does. The last line, and this is the important one. Any data variable that is used in that module needs to be listed. And I'll explain to you why that is. That's probably the most important one. Okay, that's it. The 6 lines that I just mentioned needs to go in there. And they go fast. I know it, hell, you guys will type them in faster than I just explained them. Okay? The reason why you want that last one in there is for testing purposes. When you have an issue, something's not right, there's some variable that has a wrong value in it. One of the quickest ways to find it is you do a search in your source code and say, hey, total is wrong. So you do a search, hey, find the word total. And it finds every module, every function that uses total in there. And you can jot that down, you can look at it and say, okay, now you've got a way to flow through that thing and either desk check it or put some right lines in there, some way to output it and say, okay, it's got to be happening somewhere around here because these are the only 4 modules that are touching total. That's why it's important to know which variables are being touched, either looked at, touched, changed, or whatever by any of the modules. So that's the documentation that you need, a minimum, for the coding. If you want to add some comments, inside the modules, that's always helpful, especially on things that are a little bit more complex. But if you're assigning the value 5 to a variable, let's say X, adding a comment that says, updating X with 5 is somewhat, it's like gilding the lily. It's somewhat wasteful of time. Anybody that knows that an assignment statement takes the thing on the right and assigns it to the thing on the left knows that, hey, you're just updating, you just changed the value of X to 5. So explaining it in English doesn't really help much. Okay? If there's an algorithm there, that's pretty hairy looking, with square roots and all of that, and you want to add a little explanation as to what that algorithm is doing, that would be useful. This is the Fibonacci series algorithm that's being used to determine the next cell in the I'm trying to think how do you call those damn things? Well, the word escapes me that I'm going to use. Okay, so if that makes sense to add, then yeah, you should add that. But the preamble is not an option. Every code, every module needs a preamble, and and the reason you do that, other than the reasons I already stated, it's also that what happens if a programmer gets hit by a bus and there's none of that available. That means that somebody has to walk through and try to figure out every little bit of what that code does. And let me tell you what happens in the real world. None of that really happens like that. If there's no documentation and somebody has to assign this to a new person, I can pretty much tell you that new person starts from scratch because they figure it's easier for them to take the design and the test procedures that were given to the programmer originally and just start from there and write their own code than trying to figure out what somebody else's thinking was. But if there's documentation, then there's a fighting chance that we haven't lost everything. That's all I've got. So, questions? Okay. None from Team Charlie. None from Team Charlie, All right. All right, folks. Well, keep marching on. Everybody's doing good. If you haven't had a client meeting with me yet, give me a buzz. Send me a text. Get something set up. I'm in the system today, doing a bunch of grading and checking documents that have been sent to me. So this would be a good time to send me a text if you want to, schedule something. So you guys have a good evening. If you have any questions as you try to do this thing, don't wait till the last minute. Don't wait for your client meeting. Don't wait for my weekly meetings. Send me a quick little text. If I can answer it through text, I will. If not, I'll tell you, hey, let's set up a little phone call and let's chat about it. Okay? You don't have time to be waiting a week or so for a response. So, all right, folks, y'all take care.
You too.
Talk to you soon.